Alright. About a week ago, I did an online class on wiring diagrams. And one of the things we talked about is something called strip circuits. Strip circuits take a whole wiring diagram and break it down into smaller circuits that are easier to understand and find. So this lecture today is going to include a little bit of you guys interacting and doing some things. I'm going to give you an explanation of how, and then you're going to try to figure out why or what. In the previous lectures, we talked about this. I only took out just this one part of the diagram. I'll show you here. Which one was that image? Here. So this is one page. It's still got some more stuff on the bottom of it and everything. So what I did is just took this one section of the diagram, and we're only going to talk about just this one part of the diagram so far. So looking at this diagram, one of the hard things to do is troubleshooting the machine. That's this Frigidaire dishwasher we've been talking about. And when you see this rectangular box right here, let me just highlight it, this rectangular box right here, that's the whole computer board inside the dishwasher. In older machines, you would call it a mechanical timer. It's what controls all the parts in the machine, turns them on, turns them off, tells them when to run. In this case, this computer board here is doing it. What did we say the tactile switch was? It's got another name for it. Right here, it says tactile switch. See it right there?
Yeah.
Oh, is that a,
Did you-
Is it the on and off switch?
Sort of. That's the user interface.
I think I missed
User
that day.
interface.
But I was thinking that's the user interface.
That's the
I
user
could see
interface.
it.
Those are all the buttons on the front of the dishwasher when you press cycle, start, whatever.
Okay.
That is the user interface. They call it a tactile switch, another name for it. That's connected to the main board. And so basically when you're pressing a button, it knows which button is telling which program to run and everything. But troubleshooting from that's a little hard to troubleshoot because you can't see, you see power comes into the control board, but you can't see, well, once it goes into the board, what does it do after it's in the board? There's nothing there. It's just a rectangular box. So what I wanted to do is I wanted to break down each individual circuit. Okay? And this is how I want you to look at the wiring diagram. One of the things we want to look at are the loads. In a wiring diagram, what is a load? Just a load in general. What is it?
A component that's operating like the motor,
Motor, light bulb,
fan,
fan, heating element, pump,
yeah, it draws.
anything that does a physical or some sort of function that, that's the reason why we have the machine, is that motor's gonna splash the water around to wash the dishes. The water valve is going to allow water to come into the machine. So what is the rest of this stuff that's not a load? What is the rest of the stuff inside this machine that's not a load?
Like switches.
So what do we call switches in an electrical circuit?
Controls.
They're controls. All they do is turn parts on and off. Okay? So first let's look at this diagram here and let's identify, take a minute, look at that diagram and try to figure out the loads that are in that wiring diagram. So they are the things that we want the dishwasher to turn on so it does something. Like the water valve is a load because that lets water into the machine. So count. First of all, how many loads are in this entire diagram?
Let's see.
11?
11? Okay, if we're starting right to left, what's the first one on the right?
Heater.
Is it 5?
Oh, it's
If we're starting right to left, what's the first
Water
one?
valve. I said
What?
The
water
dispenser.
valve.
The dispenser.
The dispenser.
Oh.
So maybe 12.
Okay, So that is a symbol for a wax motor. A wax motor on a machine is just a little heater that's got like wax inside of it. When it's heated, the wax expands, so it pushes a plunger out, and then when it cools down, the wax contracts and a spring pulls it back. Okay, that's a symbol for a wax motor. So then we already said water valve, that's 2. What's the next load?
Float switch.
No, the float switch is a switch. A switch is a control. What does the float
Water
switch
valve.
control?
The water
The
valve.
water valve. The float switch turns the water valve on or off, so it's controlling the water valve. So it's a control. What's the next load in that circuit right there?
Drain motor.
The drain motor. What else?
The
Pump motor.
Pump motor.
Pump motor.
The,
Anything else?
The heater?
The heater.
Now, Mr. Rich, is the thermostat considered a load or considered a switch? I know it's like a thermostat, but which is it?
It's more like a load.
With the resistance?
It is a resistor
Right.
that when heated or cooled, the value of resistance changes. So it's more of a load that the board is looking at that load and it knows what temperature it is and it's measuring water temperature or air temperature or something. So it's a resistor, so the thermistor, and they have one here and they also have one inside of here.
Yes, I see that.
Yeah.
Is there anything else?
The heater?
The heater.
Okay, I already got a dot there. So
Oh,
it's
you already got it there?
1, 2, 3, 4, 5, 6, 7. Anything else?
Is the only thing I could ask now is the turbidity sensor a load?
I did highlight it
Oh, you already highlighted, okay.
because it has a thermistor in
Because it
there.
has 30, you said you had 2 thermistors.
And a turbidity sensor is a sensor that communicates back to the board, telling the
Okay.
board what? For those that weren't here last week, what does a turbidity sensor do?
It monitors the amount of, how dirty the water is.
Exactly.
Oh, okay, yes, you're right.
And a turbidity sensor would be right here on this one. It's not in this unit. It would be on the bottom of this pump housing assembly. Now, it may or may not have a turbidity sensor. This is for more the higher up. So it senses how dirty the water is, and what's its purpose? What did we say the purpose of that was?
It was,
To control how much water goes into the.
Not how much water, but if I'm sensing how dirty the water is, why would I be sensing how dirty the water is in the dishwasher?
Oh, because, it pumps out the water to make sure you got clean water to give.
So if we're washing dishes,
Yeah,
and it's on its first load, and it's got a lot of food running around there, well, washing dishes with the food is just like washing it with dirty water. So the turbidity sensor, we said it before, is like when you walk into a store and it beeps as you walk in, as you pass through this like gate, it beeps, like you cross a infrared line or whatever. That's what a turbidity sensor is. It's got a little infrared beam between 2 posts, and the water's forced through there when it recirculates through the pump. And as the food goes there, it blocks that infrared, creates a pulse. And if it gets too many pulses, it says, hey, this water's dirty. Throw it out. Let's put fresh water because we're never going to get the dishes clean. So the turbidity sensor is telling the board how dirty the dishwasher is. Okay, so we can add washing time, we can add water, drain it out, put fresh water. That turbidity sensor is communicating to the board. Okay, so are we done with the loads?
no, we have a user interface.
Well, the user interface is not a load,
It's not.
that it's like a switch.
yes, it's
Oh,
When you
okay.
press a button, it's completing a circuit to program the board to do something.
So then, yeah, well, I'm pretty sure we.
How about the control board?
There you go.
Now, it's both a control and a load.
uh-huh.
Okay, as a load, it lights up, it keeps track of time, okay? So it's, if you go to the machine and the machine's dead, one of the things you wanna know is, do I got power to my board? Cause it's not lighting up, my board's bad. That is the load side of it. Somewhere on these boards, there's a little transformer that that does that, okay? Now, the other thing is, it's a control. It has a bunch of switches mounted on the board that turns on the other loads, which we use what we call relays, okay? So here's the thing. Let's take a look at the dispenser. Now, somebody want to come up here and highlight the circuit just for the dispenser, how power flows in, goes through the board, goes through the dispenser and back out? Someone want to come up here and try that for me? All right, sir. I got our first guinea pig
First
here.
victim.
For the victim.
So power's gonna start here on line 1 and end there, and we're going to energize the dispenser. So how is power going through the dispenser?
So the power comes here when it energized and it closes the switches right here, what brings you back to the neutral and brings you back to the dispenser?
Wait, show me the circuit. Like, how would
Oh.
you think electricity go through? Just touch it and create the circuit.
Okay, how did I say power come in, boom, boom,
No,
no,
that's a mechanical link. Those two switches are linked together. So when one moves, they both move.
right,
So it goes straight up, but it doesn't jump over.
oh, okay, so it goes here,
And we go into the board.
and we go into the board. Oh. Wait a minute.
Go ahead, I know, this is hard. I mean, if you're not sure, you're looking at that board, you say, okay, now what's going on? I just see a rectangular box, right? But we gotta come out here, right?
Yeah, we gotta come back
So
here.
you gotta connect this to this. Just draw a line to it, through the board.
Just through the board?
Up and over, up, not
Oh,
through all that.
okay.
Just go up and over it and
Oh,
all the way
okay,
over
okay,
here.
I'll look
So
at
let's
it.
stop just for 1 second. So somewhere here on the board is a switch.
Okay.
That would be a relay. So when a board wanted a dispenser, it'd close that switch and send power there, right?
Okay.
So where's the rest of that circuit?
Where's the?
Go through the dispenser, where does it go from there?
Mm.
Okay, very good. So that's how power goes through that diagram, just to energize the dispenser. Now, what we could do is we could take and make this into a straight circuit, like a strip circuit. So we see how power comes in, goes through here, goes through here, goes through here. We do it like this. We start here, we're line 1 and neutral. Line 1 and neutral are is the outlet on the wall where power's coming in, okay? So you got line 1 here.
You know what I'm at?
And we go through what? What is this right here?
Door switch.
It's a door switch. So we're gonna go through a switch on the door, and I'll put it here. And where do we go from there? From the door switch, where do we go next?
It goes,
What are we going to here?
it goes.
Oh, the relay on the board.
Okay, we go to the board, and we go to P1. So if we go like this and draw a little box,
Mm-hmm.
and say P1,
P1.
that little box is representing the terminal on the board.
Yeah.
P1 is plug number 1, P2 is plug number 2, pin number 3. Okay, so the P's are the plugs. So if I looked at this board, how many different plugs are connected to that board according to the diagram? Don't count boxes, look at for the P identifications. How many different ones do we have that have the P?
14?
1 through,
Not
1
14,
through 10?
like P1.
Oh, they have the P, okay.
I'm not talking about each one of these
13
lines.
then.
P1 is one of them, right?
It's a 6.
There's 6.
P8
Say
is the
14.
1, 2, 3, 4,
1,
6.
2,
16, right?
Not 16. Wait.
6.
I said 8 because
Said
P8 is
eight?
the last that's.
C8.
Well, let's take a look. P1 is 1.
Uh-huh.
P3 is another. This is all one plug.
2.
Oh, okay, yeah.
This is
Yeah.
P2 and this is
1, 2, 3,
P2.
4,
Even
5.
though they're drawn separately, they're the same plug. That's why they're called P2. They're just, you're gonna see them a little separate, so that's 3, P8 is 4, and P4 is 5. There's only 5 different plugs on that board.
Yeah.
Y'all see that?
Yeah.
2, 3.
So if we opened up this dishwasher again and you looked at that board, you'd see 5 different connectors with wires on them. And if we were looking at P3, how many wires would you see? Wires on P3?
Was it 9? 10?
9.
9?
Oh, no.
Eight.
Watch. 1, 2,
No,
3, 4, 5, 6, 7, 8. There is a pin there, but there's no wire going there, right?
No.
Right,
Y'all see that?
yeah.
Okay, I'm not gonna go through each plug. Let's continue where we were here. So we go to P1 here on the board, and now we're connected to the board. And I'm just gonna do this. I'll just put board. And there is a switch there. You have to assume that switch is there. It's not drawn for you, but a lot of times when you look at a computer board in a wiring diagram, you're just looking at a box. You're not seeing all the individual switches all the time. They are drawn sometimes. Okay, so when we go into the board, where do we come out of the board?
P301.
P31, right? So then we got another box over here. It says P31-1.
Yes.
I don't have the room to draw it, but that's this point and this point on the board, and that's how we would see it in a strip diagram, right? So where does P31 go? What does it go to next?
To the dispenser.
To the dispenser. So then we're gonna go here, I put a little rectangular box, and then we're gonna draw an angle wire like this, and we'll call it dispenser. Oops, let me just. So that's the dispenser. Where do we go from there?
To the
To the neutral?
To the neutral, but you're missing
door
something.
switch.
There's another door switch on the other side, right? We come over here,
Yeah.
we got another door switch on the other side, right? So we're gonna go over here, and we go to neutral, and I'm gonna put this door switch. So, what's important about that? Why is that important?
Why is what important?
Just that strip circuit that I drew.
Okay.
So everything is on one circuit, so you can test each component, right there on that same circuit.
You are right, but I don't think everybody understood you, but like, okay, so we did the circuit for the dispenser. What does the dispenser do?
Dispenses
So.
The soap.
The soap, right? It lets the soap in the dishwasher. So why would I even look at this? A customer called me out and tell me, hey, the dishwasher ran through the cycle, but I opened up the door and it still has the soap in the soap cup. It didn't dispense the soap. That's what the customer called me out for. Or maybe they don't even know and they says, well, my dishes aren't coming clean. And you go and you say, hey, there's soap's in here. It never dropped the soap, right? I know, it's a funny joke, but anyways. When I see that the dispenser's not working, dispenser itself could be the fault, right? Yeah, dispenser, but we don't just change the dispenser. We have controls that control that dispenser. And by doing a strip circuit, it's easier to see all the parts that electricity has to go through so that dispenser can work. And it doesn't matter if we have a switch on this side or that side or both sides. If a switch is broken anywhere in that circuit, that part will not function. So this strip circuit makes it easier for me to see. Okay, if my dispenser's not working, I have 2 switches on the door. If either one of them are bad, I wouldn't get the dispenser to work, right? What about the relay on the board? Yeah, or the dispenser itself, right?
Mhm.
So let's talk a little bit about troubleshooting before we even go on to another part and make the next circuit. You go to a machine, the machine's not working. Dispenser don't come out, but you press start and you hear water coming in. Oh, water's coming in, huh? That's the, how about you hear the drain pump run? What's the first thing you usually hear when you turn on the dishwasher?
The drain pump.
The drain pump usually comes on first because the cycle previously might have left a little bit of residual water. We want to try to pump that out before we put fresh water in. So let's assume the drain pump is running. You press start and you hear the drain pump running and you hear a little bit of water shoot into the sink and the garbage disposal. Is that helpful for troubleshooting?
No.
How does that help you for troubleshooting?
Unless you know your water valve is working.
And the pump is.
No, we're talking about the
Oh,
drain pump.
Oh, the drain pump, oh.
It's,
Oh, the
Letting you know the
circulation
pump
pump.
working.
No, drain pump.
Just the drain pump?
What'd you say, sir?
It letting you know the drain pump is working.
It let me know, but it lets me know more than that.
Okay.
What more does it tell me?
water pump. It's-
Well, I know I got power in the
Yeah.
machine,
Yeah,
because if I didn't have power to the machine, it wouldn't do anything, right? Okay, so let's do this. Here's the drain pump, right? Is it follow this exact circuit, or does it have its own path?
It's gonna be a
it
different
has its
path.
own path.
It's gonna be a different path. Now, some parts in the circuit, it may share with the machine, but some parts have to be separate, because if it's not separate, when I turn on the dispenser, the drain pump would run at the same time. I have to have a way to control each one independently. So let's go ahead and take a look at the drain circuit. So instead of you coming up here, what's the first thing, if I start here at line 1, what's the first thing that it goes through to feed the drain pump?
The door switch.
The door switch. Is that the same as the door switch above it? Is that the same switch? Yes, it's the
Yeah,
same
it's the
switch
same
coming to
switch.
P1, so we're gonna come here to P1 again. We're going into P1, now we're going into the board through that door switch, right? But, do I use that same relay the dispenser uses?
No.
Because if I use the same relay when the dispenser's on, it would be on too, right? So I gotta have a different relay. So when I come in here, I got another relay here. It's gonna feed my drain pump. So I'm gonna go to the board. This is P1 like the other one. I'm gonna go here. And I'm gonna come out the board where? Where am I coming out of the board this time?
To, the drain.
P3?
P3 what?
P3, 4.
P3 4. So I'm gonna go be here, P3 4. I'm coming out, I know it's a little hard to read, P3 4, and then from there, where do I go?
Drain pump.
The drain motor.
Yeah, motor.
It could be a drain pump. I'm just gonna put the word drain. And then from the drain pump, I go where?
Like neutral.
Back to neutral.
Through what? The other door
Door
switch. Okay, so it's important that I show you this. And I could have picked the drain pump, I could have picked the water valve, I could have picked the wash motor. But remember, troubleshooting, everybody thinks troubleshooting is, I'm gonna go right to that machine, I'm gonna say, okay, it's not draining, let me get my meter out, I'm gonna start testing. I'm gonna look at the diagram, I'm gonna check this, I'm gonna check this, I'm gonna check that. But if you see what parts are working and what parts aren't working, we could start eliminating things we do not have to test before we even break it apart. Because if this door switch was bad, my dispenser wouldn't work, power wouldn't get there. But that's the same door switch that my drain pump uses, and my drain pump's working. So what does that mean about my door switch?
It's faulty.
It's good. It's the same switch for the drain pump as the dispenser and the water valve and the wash motor. They all go through that switch.
Right.
So if that switch was to fail, what do you think the customer's complaint would be?
No power. Or not, the unit not working or not.
not this.
It would light up,
It would light
but it
up.
wouldn't work.
It wouldn't work.
And the only reason why I say that is you got another black and white wire from line 1 to neutral running to the board independently.
Oh, yeah.
And these two are the transformer that feeds the whole board. So the board would the board itself doesn't go through the door switches, but all of the other loads go through the door switch. So if either one of those door switches were bad, you wouldn't drain, you wouldn't fill, you wouldn't wash, you wouldn't dispense detergent, the heat, nothing would work, but the board would light up, it may even count down. The higher end ones may say door, or give you a warning, the door's not closed, but that would be the type of problem you have. So if the dispenser's not working but your drain's working, we can rule out this door switch because we said that this is working, and I can rule out this door switch, which is the other side. Now I had 1, 2, 3, 4 things that could be bad. I just eliminated 2. It's either my dispenser or my board. That's it. So I went from 4 possible parts that could be wrong, narrowed it down just by looking what's working and what's not working. So if I try to figure out something's not working, I look at its circuit. I look at another part, say this part's working, do they share some parts? And if they do, the parts that they share have to be good. So what I do is I take my eraser here, and I just erase all this up to this point now. Now, that's all I gotta test. Could be many ways to check it. One of the ways we could check it is how much power goes to my dispenser. Does anybody know?
To your dispenser?
120?
120, it comes in line 1, goes to the dispenser back to neutral. Line 1 to neutral, it tells you right there is 120 volts. So I could do one thing, I could take a test cord. I could take a test cord like this, one that has different terminals on it, plug this right into the dispenser and plug it into the wall and see if the dispenser dispenses. If it dispenses, what do I do now?
If it dispenses, I mean, your board is the problem.
Change the board.
Change the board.
That's it.
Yeah,
So I only made one test and I've already found the problem.
yeah.
One test. But you need to know to read the diagram so you can narrow down the things I have to check.
The board is the computer board?
Yes, sir. The computer board is like the brain. Like your eyes, you're talking, you're breathing, your hands moving. Your computer board's doing the same thing. It's controlling all these parts independently, like your brain's controlling your hands, your eyes, and everything else. Okay? But I could also do another way, right? I could take a voltmeter and put a meter, I could take a voltmeter and put a meter lead here, and see if I have 120 volts. If I have 120 volts, like the machine is sending power, and it's not working, what do I do?
It's the
I have-
dispenser.
The dispenser's bad.
It's bad.
Because not only if I have 120 and it don't work, it's bad, but if I have 120, I know the board is
It's
sending
sending,
the
right.
power, so it's not the board. So you see how I look at this crazy diagram with all these waves and curves, and I can say, oh, it goes like this, check that first. And the only way you're going to get to that level is you gotta constantly look at these diagrams when you're working on machines out there. Get the diagram, not just look at the part, not just test the part with a meter. Try to figure out the circuit of that part. And if you don't know the circuit, call me and say, hey, I'm trying to figure out how this thing is getting power, how it's working. I can't follow through this diagram. Call me. Because I want you to see those circuits. It's the same thing with the light board. You're just practicing tracing circuits. If you can trace the circuit of a part, by finding that circuit, you know what parts you need to test to troubleshoot. And we can make it smaller and smaller. If we could say what parts are working, what parts are not, we might be able to eliminate them so we're not having to test 10 or 20 parts. But that is the troubleshooting of it. So let's take this diagram here. Okay, hold on one second. Alright. So, no loads are working. The board lights up. So, board lights up. I showed you a little bit. This is the circuit for the control board. Power comes in line 1 here, goes through here, and goes into the board here. On the board, there's a transformer that feeds the whole control board, because even though 120 volts goes to a control board, most control boards are low voltage and mainly DC. So there's a transformer on most boards, or there's a transformer before the board that sends low voltage to the board, that board will light up. So we come out this other side here, which is neutral. Am I going through those door switches now? Did I draw a line through the actual switch?
Yeah.
Did I go through that door switch?
Oh,
No.
No. So we don't want it to go through the door switch at that time, because if you're in the middle of a cycle and you're like, or it just started, let's say running 3 or 4 minutes, you're like, oh man, I forgot to put these plates in the dishwasher. You open up the dishwasher. Once you open it, these 2 door switches open. What happens to all these parts? They all stop. But the board stops wherever it is in the cycle, and when you close the door and press start again, it just continues from that point on. It doesn't go all the way back to the beginning and start the whole thing over unless I cancel the cycle. Same thing like a microwave. You all have cooked with a microwave, right? How many times have you all put 2 minutes on the microwave and then a minute in you opened up the door? Well, if you close the door, you press start, it's gonna continue from that minute, right? So is that board in a microwave, the power of that board going through the door switch?
No.
No. Otherwise, the board would lose power, which means it would lose the program memory, and it would start all over again, and you'd have to press cook, time, start, all over again. So the door switch doesn't control the power for the board, but it does go through the board as an electrical circuit for these components. So if I called you out and said, hey, my dishwasher lights up, but nothing happens. I sat there for 20 minutes, let it run. Nothing happened.
Door switch.
Could be a door switch.
Be a computer board.
Could be a bad board.
Could be a bad board.
So how do we approach that? Where do we test and what do we test for? Because it's either gonna be the board, because the board tells these things to run, or the door switch. It's not my power supply because the board is lighting up. The board is acting like it's going through a cycle, just I don't see any of the parts running. So what kind of test would I make, or where would I make a test to say, oh, my problem's my door switch, my problem's my board?
Is it P1 and P3?
P1 and P3 what?
P36.
Okay, so here's P1, here. Where's P36?
Where is P36? It's on the other,
It's down beneath it.
Well, let me ask you a question. Let's just say, we said the drain pump's the first thing to come on. When I go here, and I go through the drain pump, and go back here,
oh, yeah.
neutral here on P36 is only for the board to light up.
P1 and neutral.
P1 and neutral.
Yeah.
Okay, I'm gonna get to that in a second. Let me explain something. Here's a light bulb. Let's just say this fluorescent light right here. I wanna turn this light off. So I go over here, I'm gonna turn off more than one, but I'm gonna turn this off, right? Turn that switch, turn the light on and off, something simple. So I got a switch, I only did one switch, right? So if I draw a switch here, do I have line 1 here and neutral here?
No, you have line 1 going to the load, and you got neutral going to the other side of the load.
Okay, so here's my question. In that box where that switch was that I just turned on the wall, the light switch on the wall,
Mhm.
is there line one and neutral going to
Yes.
that switch?
Yes.
Yes,
No.
no?
Oh, no?
Light switches on your wall only break one side of the electrical circuit.
Yeah, line one.
You don't have line one and neutral at
Line
that
one
switch.
around.
You have line one going to the switch, but on the other side of the switch, if you close it, it takes the line one to the light,
Right.
which is this wire here. We don't have a neutral here.
We have a
If I
ground.
put line one here and neutral here,
Right.
it blow up. Because line one and neutral can't touch each other. So line one's here, my neutral is on the other side of my load. My load is what separates it. So in the wall, let's just say you wanted to put an outlet right next to those switches. You got two light switches or a light switch in the bathroom, and you want to put an outlet right next to it. You have no neutral there to put an outlet. Now, they may have a neutral inside the box, but it's not connected to the switch. But neutral and line one do not connect to the same switch. That make sense? Okay, so when we go back here, we have line one here, that's line one here coming in. Yes, this is neutral here, but it's not going through that door switch to get there. The door switch neutral only goes to my loads. So how would you test it? And what I'm trying to say is, we still have to determine whether it's my board or my door switches. Do we always have to do a voltage test?
No.
What test could we do?
We can do
Resistance?
a resistance test.
Resistance or ohms
Ohms
test?
test.
And what type of ohms test would you do?
For a board.
Well, we could either check the switches or the board. Which would you check?
I will check the
Check
switch.
switches?
I check the switches, right?
Mhm.
So I look at the door switch here on the dishwasher, and this is black wire here, black wire here. This is what? White wire here, white wire here. So when I look at the door switch, let me find a picture, because I don't have that dishwasher open right now, but just give me a second here. So we got a door switch here. Actually, that wasn't a good picture. I want to go back to this one here. This one looks good. You can see it. Oops. So if you look, the little dots on the door switch, what are those little dots?
Representing the pins on the actual switch on both sides of
The connector where you connect the
Connector,
wires,
yeah.
like here, these are relays on the board, and these little places where you connect the wires. Those dots on all these switches and stuff are where the wires are connected to them. Okay? So if you look, one switch has two black wires, and one switch has two white wires. So if I go here, I'll put BK, and I run that wire to this pin, and this other pin, I got BK. And those two pins would be these two pins on the board. That's where you put your meter to check that switch. So over here, and I'll use a different color, I'm not gonna use white because you won't see it, but this would be the white wire coming in, and this would be the white wire coming out. You would check those two pins if you're checking that switch. And that's how you would check the switch. So you could unplug the machine, and with a meter without it live, we would do an ohms or resistance test to see if that switch is good or bad. Now, if both of those switches gave me a reading of 0 ohms, is that good or bad?
That's good.
Good.
That's good. What is a bad switch reading?
OL.
OL, which is another word that starts with I. What did Buzz Lightyear say? 2 and beyond?
And infinity and beyond.
Infinity. And infinite.
Infinite. That's right. Infinite.
Okay? So If the switch is bad, the digital meters say OL, but if it's an analog meter, it don't say nothing, you have to read it. And that means infinite, means it's open. Infinite's another example for like total resistance, no electricity can pass through.
Is that the funny H shape? Yeah,
That's means infinite. And you know, it's on the analog meters.
yeah, it's actually on
Let me show somebody, cause they might not know what we're talking
there.
about.
Mhm.
So, I forgot what that meter was that I got from Amazon, but let's go there. We can use this one. You know, it's not the one I got. I was looking for mine. Oh well, we'll use this one here. So if we look at this face of the meter here,
Mhm.
analog meter, hard for people to read because you guys are used to digital. It just gives you a number and you're all lazy.
Pretty much.
Remember, I started learning this back in 1981. We didn't have digital. We didn't have cell phones, we didn't have computers. Cable TV just came out, MTV was the channel to watch.
Yeah.
Okay, so on ohms, and this is what this omega symbol is right here, that's the resistance scale at the very top that we're going to read ohms. This scale in here is for DC, AC is the red scale, so for reading DC volts, 250, 50, or 10, depending on where my scale is. I'm not gonna get into deep on that, but if I put it on there and my line is drawn right across there, that'd be 250, oops, let me put this back over here. 250 volts, 50 or 10, depending on the scale of the meter. If I'm doing voltage, 0 is here, and the highest reading is here. That's as high as that scale read was 250 volts. If I had 260, the needle will peg, what happened, I lost it? The needle will peg all the way over. Okay, now when we're doing ohms, notice that the volts 0 is here, the ohm 0 is on the right-hand side. We actually read right to left with the ohm scale. And the reason why I do is just the way the meter works. The meter uses its own battery, so when we connect it to check across a switch, the meter sends a little electrical current. If the switch is closed, the needle's gonna give me a reading. If the switch is closed, it should go all the way to 0. Okay?
Mhm.
Oops. What did I do there? So it'd go all the way to 0. Right there, you see the number 8 sideways?
Mhm.
Well, that needle's pointing at that right now, isn't it?
Mhm.
That's infinite number of resistance. That means the switch is open. It's not making connection.
Mhm.
All
I
right?
was gonna ask that, yeah.
So if I'm checking a door switch, what do I do? What do I have to do to test it? What steps do I gotta take to properly check a door switch?
Isolate it from.
Well,
the
first
actual-
thing we do what?
Cut the power off.
Cut the power.
Cut the
Let's
power.
just,
Do
let's
safety,
do the
yeah.
safety first. Cut the power.
Mhm.
Put on our safety gloves
Put on
now
our
so we don't
safety
get
gloves.
cut or shocked, right?
Mhm.
Now, let's say we opened up the machine. We got into where the door switch is now, and I can see the door switch.
Mhm.
What more do I have to do before I test the door switch?
Isolate the door switch from the rest of the circuit.
So we gotta disconnect the
Disconnect,
wires,
yeah, disconnect.
because if I leave the wires connected to the switch, and if we look at this diagram again, let's go back to the diagram for a second here. If we look at this, if I don't disconnect one of these wires and I touch here and touch here, it's possible it could read through here, back to here, through the board, and backfeed, give me some false reading that I'm not looking for. So by taking wires off and touching just the pins, like the picture of this switch, just checking the pins, I'm making sure that I'm not checking anything else in the machine. So you at least have to pull one wire out of the 2 wires that are connected to a part to make sure that when your meter's on that part, that that is what you're testing, and you're not reading through the wires back through something else in the machine. That's isolating. But there is one more thing you have to do. You checked the door switch the other day, both of you. What did you have to do before you could test it? you remember?
Before we tested it.
In order to test it, you had to do something. Come on. You check the lid switch of a washer, what do you gotta do?
Oh, you gotta open and close it.
Right?
Well,
On a
yeah.
dishwasher,
Yeah.
we have to close the door with the
Yeah.
switch and engage the
Yeah.
switch. If I have the door open, the switch is gonna be open, because when does the switch close? When I close and lock the door. So we have to pull the wires off and close the door so that the switch contact's close. Does that make sense?
Yes.
Okay, so that's the door switch. So if any one of those contacts were fail, the board would still light up, but nothing else in the machine would operate. Let me put the diagram again. Well, you know what? I have to go back. I think I had the door switch copied and not the board. Okay, here. All right. I'm gonna give you the circuit. On your own, take a minute, write down all the things you would test, that everything seems to be working, but the dishes aren't dry at the end of the cycle. What parts would you test? Remember, I said, everything's working, but the dishwasher's not drying the dishes. This is the customer's complaint. You have the circuit, I highlighted it for you, showing how power's going through. Take a minute and try to identify all the things you would test. Now, while you're all doing that, just so you can listen, a technician on average should not spend more than 10 to 15 minutes diagnosing the fault in a machine. If you're spending more than 10 to 15 minutes trying to find the problem, I tell my technicians, you pick up the phone, you call me, or you call technical support, because you're gonna be stuck there all day. You might find a problem, but guys run 10, I used to run up to 15 calls a day in an 8-hour day. I can't be spending more than 15 minutes in a house to try to troubleshoot it, because I got other jobs waiting for me. So you have to be efficient at this, and you have to be able to read the diagram. You have to be able to take what's working and what's not working and deduce what the problem most likely is in the machine. Has anybody got an answer of what we would test?
I'll do the rinse,
Okay, wait, raise your hand, because everybody yelling out. Go ahead,
the
operator.
rinse and level sensor.
No, because am I going through the heater with that yellow line?
Nope.
So that's not in that circuit. The rinse level sensor is, we put in the dishwasher something called jet dry. It's a liquid, and at the very last cycle, the last rinse cycle, before we go into dry, we dispense this liquid. It's like Rain-X when you put on your windshield and the rain come off. It's the same idea, that it sheets the water off your glasses so your glasses dry better. So, someone got an idea? Gene, you got one?
Yeah,
Which one?
the door switch, the heater, the element thermostat.
No, hold on, one thing.
Oh, only one,
Yes. One, give me one thing.
the door switch.
No. Why not the door switch? He said door switch, I say no. Am I right? Am I wrong?
Oh, because we already checked the door switch is working.
I said everything else is working. Everything works. Just at the end of the cycle, the clothes aren't dry.
Oh,
So we're looking at the heater circuit, because the heater circuit is what dries the dishes, right?
Yeah.
Okay, so anybody else? Hold on, Jim, let's see anybody else? Yes, Ricardo?
The heater?
The heater. I'd check the heater. What kind of test would you do on the heater?
Ohms?
You could do Ohms test. Can you do any other tests?
The voltage or the,
So when we do a voltage test, what do we have to do to make a voltage test? If what I wanna do is, if I got power here and the heater don't work, I know the heater's bad. But how do I know there's power there? What do I have to do to check power there?
You can take your meter leads and check it for them.
Yes, but I have to do something else. I can't just put my meter leads on there, cause do I have power there all the time?
No.
When do
You
I have
to close
power?
the door.
Has to be plugged in, but I need more.
Yeah, you have to, plug in, close the
You have to
door.
turn it on.
Hold on. Y'all close, but let me get to this. Where's my diagram at here? I know I have it. Here we go. You have to go to this cycle chart that we talked about the other day. And I have to know, there's my heater, right? It says heater right there. It says it multiple times. I'm just looking at this cycle here. This cycle is what the machine's gonna do. Once you turn it on, as we go, these dark lines are telling me what parts are being turned on and when they're being turned on. The down here is the time frame in minutes. When I first turn it on, I'm here, and you can see that the water valve has got like a little black line there, and it's there for only 2 minutes. Once we hit that second 2-minute mark, it's not highlighted anymore. So that water valve's only giving power for the first 2 minutes of the cycle. Is there anything else running? The vent is energized as well.
Mhm.
You got a question?
So you're saying based upon the time cycles, it's only important to test, say, for voltage if within this range, either something's open or closed or alive, basically.
Well, what I need to do is I need to look at the heater and find out where in this cycle is the heater supposed to be turned on. Because you turn on a dishwasher, my heater don't come on till after what? What time am I on this timeline here that heater circuit is energized?
Like a few minutes after the main
A
wash.
few minutes? No. What number? Give me the exact number.
Oh, okay.
17.
17.
17, yeah.
So if I turn that dishwasher on, I'd have to wait 17 minutes
Before the
for
heat.
power to get there. Now, when you're waiting for something, you never heard that story about, can't wait for watch a pot boil because it takes forever? It's not that it takes forever, it's just people are impatient. They expect everything like microwave, turn it on and let it go.
Right.
But is there a way to energize that element using the control board where I don't have to wait 17 minutes?
Yeah, you can test the points.
Oh, diagnostic mode.
Water service test. That's a diagnostic mode. Look here, where does it say that the heater comes on? In step number 3, right?
Mhm.
It says it washes and the heater's on. So it tells you here, when you first turn it on, it's gonna fill and the detergent dispenser's gonna get energized. It's gonna last 60 seconds, 1 minute. After that, it's gonna go to step 2 and it's gonna fill some more for up to 27 more seconds because most fill cycles are 1.5 to 2 minutes long. So they continue to fill. So after 1.5 minutes, the water come on and the heater come on. So I could almost time myself on my watch, go into the diagnostics, and here's the instructions on how to do it. And when we get this one back together, if you want, you guys can try to do that. But I want to go here, get it into this diagnostic mode here and let it go. And it moves by itself step by step. But I look at my watch and said, okay, after 1.5 minutes, it's going to stop filling, it's going to start washing. So what I'm going to hear the water valve turn off and the wash motor turn on. At that same time, what else is going to happen? The heat's going to come
The
on.
heat's gonna come on, yeah.
And at that point, I can troubleshoot that out.
Okay.
Does that make sense?
Yeah.
So I don't have to wait 17 minutes, I only wait 1.5 minutes. That's reasonable.
Right.
I'm not gonna sit in the customer's house for 17 minutes. Now, another cycle is you could go into a cycle that's, rinse and dry or drain cycle where it just runs the last half of the cycle. But if I didn't have voltage there at the heater, let's just say I waited 2 minutes. I'm in the middle of this wash heat cycle. What what do we do now if we don't have power at that point? We know now, by my watch, I'm already 2 minutes into the cycle. 2 minutes into the cycle is definitely gonna put me in the middle of that wash heat, right?
Do we check power at the board? Or we check the board to see if it's sending power to the heater?
How would you test that?
You will check P8.
Okay, so let me go back to my other diagram here. So
P8 to.
I'm gonna put one of my meter leads on P8, and where am I gonna put my other meter lead?
To neutral.
Well, I'm at the board, that heating element's all the way underneath the dishwasher. I'm already up in the control panel on
Oh,
the top
okay,
of the
okay.
dishwasher. So I can go in the bottom and find a neutral, but where else could I find a neutral while I'm up there? Is there a neutral up there on the board?
Is it P? No, it is. Neutral going to P37.
Yeah.
So this is what? What is P8? Is it line one or neutral?
Line 1.
It's line one, because line one coming in and going here, this is neutral. So if I put my meter here and here, and I have 120 volts, what do I do now?
Well, at least if you got 120 volts, you know your board is sending power, trying to send voltage.
Okay, we know the board's sending power,
Yeah.
but we still don't know what the problem is, do we?
Nope.
Because we went here and we had 0 volts.
Right.
Well, now what?
Check your high limit.
High limit, we can ohm it out,
Yeah.
we can do voltage.
Mhm.
I can take this meter lead here, this one right here, oh, no, can't separate it, but I take this one and move it back to the board. If I have voltage here and don't have voltage there, I lost it across the thermostat. It was coming out the board, but never made it to my heater. What's in between is that thermistor or thermostat, and I change it, and I'm done. I found my problem. Now, if I wanted, I could take a test cord, put it on the heater and see if the heater got hot, right?
Right. Mhm. That's true.
All right. Any questions on what we did today? So I have an assignment for you for tomorrow, and I want to go over it tomorrow. So I didn't put lecture on the agenda for tomorrow, but let's pick this up for tomorrow. Okay? But your assignment. Let me just stop this here.